Okay, guys, we are starting a brand new unit today. In Edulastic, you're going to see that this new packet is attached. Feel free to print it out, but if you don't have a printer or don't have enough paper, you can always, sorry, I'm trying to autofocus this. You can always just do it right in your notebook, okay, and follow along on the screen, okay? So we are in 8S Unit 8, Chapter 8, packet number 1, okay? And we are going to be talking about 3D figures this unit. So those are things like cylinders. You can see down here we have a cylinder, we have a cone, and we have a sphere, okay? So we are going to go ahead and we are going to get started. Okay, so we are on page 2, okay? And let's just move that out of the way so you can actually see this. Okay, so we are talking about three-dimensional figures today. A three-dimensional figure with faces that are polygons, okay, is called a polyhedron. Okay, polyhedron, okay? And most polyhedrons have 6 faces like a rectangular prism like you worked with last year, okay? Some examples are, we're going to start with cylinders, okay? Then we're going to move on to cones. Then we're going to move to spheres, and then we're going to do combinations thereof, okay? And we will work with these in this unit. So last year you worked with rectangular prisms. It says to draw a cylinder and a rectangular prism in the space below. Okay, well a cylinder I think is the easier one to draw, right? We draw a cylinder here. We've got, it would help if I could actually draw straight. There's my cylinder, okay? And people draw rectangular prisms differently. I do it this way. Okay, that's how I draw mine. It's not exactly, but it's pretty darn close, okay? And let's compare and contrast the cylinder and the rectangular prism, okay? So here we have our Venn diagram, and we're going to put the things that are in common in the middle. And if you look at this, let me get another color pen, you can see that they each have bases, okay? So they have bases. And if you look at here, here's a base, and here's a base. If you look over here, base and base. So you can actually write they both have 2 bases, okay? Another thing that they have in common is that they're 3D, okay? We know that they're 3D, and they have these, what we call lateral sides. You should have talked about that last year, okay? And lateral sides, we can see here that we have 1, 2, 3, 4, okay? They make up the outer edges of it. Here, if you look at this round one, if we were to take a can and unfold it, we'd have 2 circles, and then we'd have a rectangle if we cut this and opened it up. So we have 1 lateral side over here, okay? So let's talk about the differences, okay? If we're talking about a rectangular prism, we'll put that over here. And we'll put our cylinder over here, okay? So on the rectangular prism side, we can see that our base is a rectangle, okay? As opposed to a cylinder, where our base is what? A circle, okay? There's one difference. Another difference is that, and we kind of talked about this a few seconds ago, here on this one we have 4 lateral sides, okay? On this side, we just have, 1 lateral side, okay? And those are the differences when we're talking about a rectangular prism versus a cylinder, okay? So let's go ahead and let's flip to page 3. We're going to go over here. And we are going to do just a short review. We're going to talk about the formula for the area of a circle. And you should recall that's area equals, I don't know why I did an approximate, area equals pi r squared, okay? So when you're thinking about this, and if we look at this first circle, it says to find the area of the circle, show work in the space, provide exact and approximate. We're in 8th grade now, so we're going to do both exact and approximate. You will need your calculator. Sorry about that. I should have said this. And we're going to find the area of this first circle. Area equals pi r squared. Well, my radius here, if you remember, it's half of the circle. That's 5. So area equals pi times 5 squared. 5 squared is 25. So we've got 25 pi, okay, and that is feet squared. We're not talking about 3D yet, so we're just in squared, and that's my exact. And if we do my approximate, use your little squiggly lines to show approximate. You're just going to type in 20. Let's see if we can get the glare off of there. There we go. 25 times. The pi button is right here. Okay, it's right above this little caret. You can see you're going to get second pi. And you get 78 point, they said the hundredths place, so 78.54 feet squared. Okay, so that's the area of just a sorry, I can't speak today, it's just a circle. Okay, then if we look over at B, instead of giving us the radius, they gave us the diameter. And we know the diameter is 2 times the radius. Okay, so if we have a diameter of 26, the radius is going to be 26 divided by 2, which is 13. Okay, so my area is pi r squared. I'm going to do pi times 13 squared. And we're going to get area equals 13 squared is 169 pi. And that is my exact. And you have to write exact and approximate. Okay, my approx is going to be area equals approximately. We're going to do 169 times pi. And we get 530.93. 530.93, and I forgot my labels, inches squared. Okay, so now we're going to talk about, that was our kind of our review. Okay, that was a review. Now we're going to get into the actual first 3D figure, and that's a cylinder. And we're going to talk about the volume. The volume of a cylinder. Okay, let's first talk about what this base is. Okay, when we talk about a big B or an uppercase B, we're talking about the base area. Okay, so the area of the base. Okay, and then we have height, H, I should say, which is my height. Okay, so my volume is going to equal my base, my big B, which is the area of the base, times the height. And that's always going to be in units cubed because we're in 3D now, so we're talking about cubed. And my base area, well, my base is a circle, right? It's a circle. So that's going to be pi r squared, okay, because we know it's a circle. So my actual formula, my final formula is going to be volume equals pi r squared times height. And that's units cubed, okay? So that's what you have to commit to memory. Pi r squared times h, and that is the volume for a cylinder, okay? Let's go ahead and let's flip to page 4. Okay, and let's do a couple of these, okay? We have example 2, find the volume of the cylinder. Show work in the space below, provide exact and approximate answers, and round to the nearest hundredth, okay? So here you can see that we have a radius. This is going to be our radius right here, okay? And that radius equals 4. We have a height, because if you were to turn it sideways, you can see that this is the height of the cylinder, and that's going to be 15. So we're going to write our formula. I always recommend that you write the formula first. Volume equals pi r squared times height. Okay, so we have pi. We have a radius of 4, and you're going to square it times the height, which is 15. Okay, you get volume equals pi times 16 times 15. Well, 16 times 15, you can put that in your calculator. Volume equals, that is 240 pi, and that is feet cubed. And that's my exact answer, okay? And again, we need to have exact and approximate. So I'm going to go ahead and I'm going to go over to my calculator. And I'm going to do 240 times pi. And I'm going to get 753.98. So 753.98, and that's feet cubed, okay? And there's your exact and your approximate. If we go over to this guy right here, okay? If I were you, I would stop the video and I'd try it on my own, okay? So if you want to do that, I'll pause and then come back, okay? Now you should have gotten an answer that looks like this, okay? If you look at this, you have 4 pi r squared h. My radius is 5. My height is 8.3, okay? You should have squared that. You should have gotten 207.5 pi centimeters cubed. And then putting it in your calculator, you get 651.88 centimeters cubed. Okay, and that's how you do that problem. So hopefully that worked out for you. Okay, let's just do one more on this page. I want to go to letter D. Okay, it says find the volume of the cylinder with a diameter of 8 inches and a height of 20.2. Okay, we know our formula. Volume equals pi r squared times height, and they give me a diameter. So to find the radius, we have to take the diameter divided by 2, which is 4, okay? And now we know the radius is 4. We know my height is 20.2. So I'm just going to plug those in. Volume equals pi times 4 squared times my height, which is 20.2, okay? For my exact, I'm going to get volume equals, let's see, that's let's not do that yet. Volume equals 16 times 20.2 times pi. 20.2 times 16 is going to give me 323.3 pi, and that's going to be inches cubed. Okay, there's my exact. And if I want my approx, I'm going to type that in my calculator. I'm going to get 323 point, oh, that's 0.2, I think. Sorry about that. 0.2 times pi, and I should get 1015.36. 1015.36, and that's inches cubed. Okay, good. We are on page 5, and I think this will be our last one for the day, okay? Or our last page for the day, I should say. We are on page 5, example 3. Okay, now here is a little different because now they give us the volume and they give us the radius and they ask us to find the height, okay? So if you think about it here, we have a diameter and we need the radius. So the radius equals 10 divided by 2. So the radius equals 5, okay? We're going to use our same formula we've been using. Volume equals pi r squared times height, okay? My volume, they give it to me. It's right here. It's 314. So I'm going to plug that in for volume. I have a pi. I know what my radius is. It's 5. So I'm 5 squared times my height, okay? And now I'm just going to solve for h, just like I did earlier in the year, okay? I'm just solving for my unknown variable. I've got 314 equals 5 times 5 is 25. So I've got 25 pi times h, okay? Now, just like we did earlier, we need to separate that h from this. That's multiplication, so we're going to do division. So we're going to divide by 25 pi, and we get h equals 314 over 25 pi. The pi is now in the denominator, okay, because we divided by it. And that is my exact answer, okay? And we're just talking about h, so that's just, the unit is just inches. There's no squared or cubed on it. And then if I find my approx, this is really, whoopsie, prox. Pay attention here, okay? This is important. When you're dividing, that whole 25 pi is in the denominator, so you're going to want to put that in parentheses. So we do 314 divided by, and then put your parentheses, 25 times pi, close your parentheses, and there you're going to get 3.997. We'll say that's approximately 4 inches, okay? That's how you do those types of problems. Let's do one more together, okay? We're on letter B. We have a cylinder here, and they ask us to find the height. Okay, we're going to do the same. Oh, and we're given a diameter. We need to find the radius. So the radius equals 8 divided by 2, which is 4. So we got volume equals pi r squared times height. Okay, my volume is 176. They give that to me. I'm going to plug that in. Pi, my radius is 4. Don't forget the squared, and we don't know our height. So we're going to leave it like that, okay? 176 equals pi times 16 times h. I always like to put my number in front of the pi. That's proper math. So 16 pi h, okay? And that's just like saying multiplication, okay? Same thing. I'm going to divide both sides by 16 pi, and I get my exact is h equals 176 divided by 16 pi. Okay, and that's going to be centimeters. Okay, and if I want to look at, okay, oops, I apologize, that's not the final answer, okay? If you look at your numbers, you can see that we can do some simplification, okay? You're looking to see if 16 can go into 176 evenly. And if you take 176 divided by 16, look at what happens. You get 11. So that should actually be 11 over pi centimeters. That's what your exact answer should be, 11 over pi, because you can take 176 divided by 16. Leave pi in the denominator. Okay, and then we have our approx, and that is going to be 11 divided by pi, and we're going to get 3.50 or 3.5. So h equals approximately 3.5 centimeters. Okay, and I think that is enough for today. If you want to try one on your own, you can practice this on your own. Practice on own. Okay, and you have a couple homework problems, and that's it for today.